the last question is table-driven code forms planning best practices. I have only 16 slides, so keep it short. I'll try to keep it short, about 20 minutes. Okay. So handling, maybe I'm now mainly talking about creating buffer message. There are various ways to handle TDCF. So in many cases, buffer messages are created at data processing or quality control system. So radar or wind provider data probably send the data to the data processing quality control system. And in many cases, the buffer messages are created in this server because, as Diana mentioned, one of the strongest point of TDCF is it contains quality control information in the buffer message itself. So this is also, in many cases it happens. So the data will probably proceed to send it to message switching system and goes to GTS or WIS. That is a very general way to handle this. Well, sometimes the observation equipment is sold with software to create CREX. This is a relatively new example of Japan. JMA installed the deep ocean tsunami data. It's called DART data. And actually, this equipment consists of the water pressure sensor on the bottom of the sea. And the signal is transmitted to the with the sound signal to the buoy disk, and then using the satellite communication, the data will send to JMA and processed. So actually, the CREX message, software to encode CREX message is included in the equipment, and we run the software here and then create CREX message. So some observation equipment even included software to create CREX nowadays. And also, I also talked about conversion of Tack to buffer thing. So in many centers, especially small centers, they have Tack buffer conversion software in the message switching system. So observation reports are sent to message switching system, somehow. And then the message switching system create both Tack and buffer and send both to GTS WIS. This is also the case happens all the time. So I'd like to talk a little bit about conversion. Actually, buffer data can be mechanically created from Tack data and observation station information. So as mentioned in the previous presentation, there are regulations called BC regulations, and these regulations define standardized buffer templates and how to convert traditional codes into buffer for common data such as sign-off, pilotship, and climate. So there are many off-the-shelf conversion software available. So by using this one, you can mechanically create buffer data from Tack that you already have. So conversion is a mechanical data format change. Because buffer message needs to have a location information in the data itself, you at least need to add location information like horizontal and vertical coordinates of observation stations. But other than this information, there is no meaningful additions in information compared tag. Of course, this is just a transform of the data format. So one of the rationales to migrate TDCF was actually the TDCF code include the location information along with the actual data. And this is, of course, good, but this alone actually doesn't necessarily mean the location information is more accurate than using the volume A. So conversion, well, I'm not saying conversion is not good, but conversion is not using the the strongest part of TDCF. So if you convert from Tack, and then there is some of limitation to using TDCF. So by going a little bit further to make the best use of table-driven code forms, I would like to talk about buffer template. So now you know buffer template is one of the descriptors in table D, so common sequence, but template is used, the word of template is used for referred to a common sequence that is reported as an independent message. So using buffer is all about developing a template. What I'm saying is, what kind of set of descriptors is appropriate to report this data you have? So I'm repetitive, but so besides the buffer template available for traditional reports, each user can define new buffer templates as needed. This is the most important thing about TDCF. So not only you use the existing templates, you can always define templates by yourselves. So there are some standardized templates which are developed mainly in the expert team of data representation and codes. And also, there is a way for you to develop your own templates. There are trade-offs of these among these two options. So if you use standardized templates as a good point, so you don't need to develop templates by yourself, or each workload of each center will not duplicate. And also for someone who decoding TDCF and using the data, if everyone are using a same standardized template, the coding process can be standardized as well. The good part of standardized template is a management of code tables. So descriptors, code flag tables, definitions are evaluated, tracked, and published by IPET, RMM, and WMO Secretariat. So you can just follow the WMO manual on codes publication, and you are safe to use those descriptors. On the other hand, there are some drawbacks of using standardized templates, which are standardized templates try to cover all the possible elements. So not necessarily accommodates all the physical quantities, instruments, and quality control information. So you have very specific program. If you have program or regional specific physical quantities, then it might not be covered by standardized templates. And another one is mentioned repeatedly, but some standardized templates include a lot of physical quantities, but your center might not have those elements available. In that case, the data might end up with a rather empty product filled with a lot of missing values from unavailable elements. And this actually using TDCF, but the size is rather big and with empty information. So sometimes this happens. So there are trade-offs, so good point and bad points. So I'd like to talk about a little bit about how you can develop a buffer template when in case you need some new data or product. So if you need to represent new physical quantities, you need to define new descriptors. I mean, it's an element descriptors defined in table B. And also you can define new common sequences, which is table D entries, when it is appropriate. Of course, you can define new templates. This is again one of the table D entries. So the expert team of data representation maintenance and monitoring is responsible for handling these proposal validations and amendments of manual codes. So if you want define global descriptors, table B or D, you can propose to the expert team and ask them to validate and approve it and go into the procedure of amending the manual codes to include the new descriptors you want to define. And also, as in the previous presentation, I mentioned some reserved values. So each classes have national or regional descriptors. The reserved descriptor numbers for national or regional use. So you can define national or regional descriptors also you can use. So this is not global descriptors that are managed in or maintained in the official manual on close. So the templates or descriptors can be very flexible, but the problem is your center needs to update and provide national regional codes by yourself. So the national or regional descriptors are not published by WMO. So you need to provide table include national or regional descriptors by yourself. This is your responsibility in this case. So as I said before, we can define nearly any data products. So I'll give two of examples of window provider buffer template and AWS buffer template. The development is now going on. So first one is the automatic weather stations data. And European RA6 members are developing regional standard buffer format for automatic weather station data. This is represented by the template number 3007092. And this includes these national station identifier, station instrumentation, and these physical quantities. So as a contrast, actually Japan is using a national buffer template, using a lot of actually locally defined descriptors. So for Japan's case, our AWS buffer template includes national station identifier and time station coordinates. These are the same as European ones, I think. But the physical quantities are limited to this, and we include all these statistics and period extreme values. These are very specific to Japan's product. This is because Japanese media and general public are interested in very much in statistics and extreme values. So what was the maximum or minimum temperature of the day or something, and many websites statistics. Yeah, the snow depth, 24 snow depth or sunshine. Yes, accumulation, yes. So Japan's buffer templates have those things. So as a conclusion, the templates can be very different depending on the users and elements, yeah, depending on users and how the data used. So just a comparison. In Europe, probably AWS data are floating around the countries and used by internationally. So users are very international. Contrastly, actually Japan's AWS data is actually mainly for domestic users because this is very geographical thing, but we don't have any users downstream. So AWS data is not very useful to people who are far from Japan. So that's kind of Japan specific case. So because European people are trying to standardize this AWS, so the template includes maximum set of elements, physical quantities, but not all AWS instruments cover these physical quantities, so can have a lot of missing values sometimes. So only temperature and pressure are reported, but not others or something. So in Japan's case, this is of course very localized. So we don't have any, almost never missing values. So it's kind of compact one. So we have a lot of statistics things and extreme values thing because Japanese public are interested in this data. So this is a bit the emphasis of the data are different in Europe and Japan. So the conclusion is template can be very different. So not the there is no best or correct one, but can be different depending on users. Scalable, yeah. So the second example might be is the wind profile data. And now several templates are used by European countries, Australia, China, and Japan. So these countries disseminate their wind profile data on GTS, but actually they are all using different buffer templates. And European members, led by United Kingdom, are developing a standardized buffer template, and these are submitted to the expert team, and we are now validating part of it. And in this case, they are trying two types of buffer templates for product data. This only includes the very basic data, and all the quality control and quality control information is reported separately in raw data. That's what they call. And probably the most difficult part is actually a quality control system. So as a data representation, we can define new descriptors for representing data quality, but defining the descriptor doesn't help unifying the quality control system as such. So actually, the real challenge is to have a unified quality control system that people can trust, that the quality control is done in a standardized way. So of course, in developing a buffer template, we try to unify data quality control information, but we also need to think about how to unify the quality control itself. It's not the data representations, but the observation or data processing quality control system unification. So this is a summary. So as you see, there are several ways to handle TDCF and also representing various data. So it all depends on your user requirements, business needs, information system network constraints, and available resources. So several options of off-the-shelf Tack TDCF conversion software are available. and this can be a good solution for small centers. It might be inflexible in formats for regional program-specific requirements. This is a drawback. And you can make the best use of TTCF by developing templates yourself. And this leads to kind of a good insight to observation system itself and quality control itself. So this is not only about data representation, but everything about observation. This is the last part. So, thank you.
Yeah, wow, that was a very interesting combination. Me and myself, I learned quite a lot. So first we've heard about how the code actually works, and now we know how it is best used and which strategies there are. Yes, me, I can say I'm more knowledgeable about codes now. I have no questions, but maybe there are others. Oh, good. I think that's
どういたしまして。You're welcome.
good. So, armed with this enormous TDCF knowledge, I hope that also in the next months and years, I think we have about 1.5 years left. We can now here in the sub-region successfully complete the migration of everything towards TDCF. Also the prior presentation there on the status and where maybe the gaps are is very insightful. So thank you again for providing us with this. And now one question.
Yes.
Why don't you show us the URL for both the chat Tack features related to where?
Okay.
Website.
Yes, but I need to be neutral. So yes, I can give some information. Yeah, but just having this and distribute is like advertisement, so I'm a bit nervous. But yeah, I know that. Yes. Then, so thank you for being with me. Yes.